Welcome family. In this video we are going to look at science paper 2 for the year 2021, and this paper was written by the internal candidates. Our focus will be on the section B of this same paper. We'll have question 1. The following diagram shows the changes of states in the 3 states of matter. We'll have solid, liquid and gas, then process A, B and C. Then question 8, describe the arrangement of particles in a solid. So if you look at the arrangement of particles in solid, the particles are closely packed. Now, if you look at the motion, the type of motion that occurs in solids is the one where the particles only vibrates. So say the particles are closely packed. Right, then if you look at a liquid, for these there are at least spaces, and because of those spaces the particles are able to move about. So the particles are spacely packed. Right, we move on to question B1. Say the name of the change of state labeled A and B. All right. So for process A, we are looking at the change from liquid into a gas. So this is evaporation. So evaporation is a change, or the change state of matter where a liquid changes into a gas. Then B, we are looking at a liquid changes into a solid. For example, if you put water in a refrigerator, the liquid water changes into a solid water, so we'll have freezing here. Then for process C, we are looking at solid direct into a gas. This is sublimation. Right. So our A is evaporation. Then our B is freezing. Right. Then Roman number 2, which change of states A or B is an exothermic process? Explain your answer. So from the word exothermic, we can first look at the first part, exo. So exo, it means outside or out. Then thermal or thermic has to do with heat. So exothermic kind of process or reaction, it's a reaction in which heat is given out to the environment. Then the opposite for exothermic is endothermic. So for endothermic, we are looking at where heat is absorbed, is taken into the system for reaction process to take place. Now, from the given 2, which is A or B, we want the one that we think is considered to be exothermic, where heat is given. So for this one, it is freezing, which is process B. So this one is exothermic because whenever you put a substance in a refrigerator, you are removing the heat. That's why we referred to that as cooling. So whenever you cool a substance, then heat is given out. Then that is what we are going to explain. So say because heat is given out to the surrounding. Okay, so to summarize the change of state of matter, we have we can just say some of these changes of state of matter, they are for exothermic, then the others are for endothermic. So for exothermic, you need to look at those that are used in terms of cooling. And if you look at the cooling curve, The cooling curve describes processes that are exothermic. Then if you look at heating curve, we are looking at processes that are endothermic, because for you to heat the substance, you are adding heat to that substance for the reaction to take place. Right, we move on to question B2. The following is a list of methods used to separate mixtures. The first one, we have filtration, chromatography, crystallization, distillation, fraction distillation, evaporation. Choose from the list above the suitable method that would use to. The first one, obtain pure water from sodium chloride solution. So pure water from sodium chloride solution. So we can use evaporation. Then B, separate mixture of ethanol and water. So ethanol has a boiling point of about 78 degrees Celsius. Then for pure water is 100 degrees Celsius. So the first property that we are supposed to put into consideration is the difference in boiling point. Then the other thing that we can summarize for these two substances is that they are miscible. So if they are miscible, we are saying they are able to mix to make one uniform solution. So which method can be used to separate? The first one, miscible liquids. The second one, those two miscible liquids must have different boiling point. So it's fractional distillation. Then we'll move on to question C. Obtain copper 2 sulfate crystals. So we are dealing with crystals from saturated copper 2 sulfate solution. So this is crystallization. Then D, obtain barium sulfate from a mixture of barium sulfate and sodium nitrate. So let's look at the nature of barium sulfate. So this is an insoluble salt. So if this is an insoluble salt, we are dealing with the method that we can use to separate insoluble from a solution, because sodium nitrate is a soluble salt. So this one is in a solution form. So we can use filtration. So whenever we filter these two mixtures, the insoluble barium sulfate will remain on the filter paper, while the sodium nitrate, which is insoluble, will be collected in the collecting beaker as the filtrate. Then E, separate colored substances in a sample of a soft drink. This is a chromatography. Right, so we move on to question 3. The following table shows the structures of 4 particles P, Q, R, and T. So remember, the particles here, these are just atoms. The reason why we are saying atoms is because they consist of these 3 subatomic particles, protons, neutrons, and electrons. Or from the definition of the atoms, we know that atoms can be defined as the smallest particle. So whenever we deal with a particle, we are indirectly looking at the atom. So we have 4 atoms denoted by letter P, Q, R, and T. Now question A, which particle is neutral? So for a particle to be neutral, the number of protons with a positive charge must be equal to the number of electrons with a negative charge. So whenever this condition is met, such an atom is considered neutral. So P is neutral because we have 11 protons and 11 electrons. So if we were to do math here, these will cancel because we have positive and negative. Then we have another one. Q is also neutral So it's 11, 11. Then R and T, these are not neutral. Then question B, which particle is a negative ion? State its charge. So negative ion, we are looking at where the electrons are greater than protons. So that's a picture from a negative ion. And a negative ion is only achieved when an element has gained electrons. Then let's look at we are going to look at R and T because P and Q we've considered them to be neutral, so those do not have a charge, so our focus will be on the R and T. Now let's look at the number of protons for R. It's 12. Then electrons is 10. So for this one, the number of protons are greater than the number of electrons, so this has a positive charge. Then for T, protons are less than electrons, so this has a negative charge. So that's what you need to look at whenever you're dealing with a question like this one. So if the number of electrons are greater than the number of protons, then you are dealing with a negative charge. If the number of electrons are less than the number of protons, you are dealing with a positive charge. So particle T is what we are looking at. Then the charge is, we just have to do the math here. So let's do the math. So the protons are 8, so we say positive 8. Then minus 10 will give us negative 2. So this is our charge, negative 2 here. It means it gains 2 extra electrons. Which two particles are isotopes? Give a reason for your answer. Now for particles or atoms to be isotopes, the mass number must differ while the atomic number must be the same. So let's find the mass number for the first one. So mass number for this one will be, we are going to add the number of protons plus the number of neutrons. So 11 plus 12 will give us 23. Then the mass number for Q will be 11 plus 13. So 11 plus 13 will give us 24. So you can see that P has a mass number of 23 while Q has a mass number of 24. So this qualifies to be isotope. So say particle P and Q. Then a reason will say because they have different number of neutrons. So they have different number of neutrons, but same atomic number. So that's our focus. Okay, so now we move on to question D. Use the periodic table to identify particle R. So let's look at this one. Right, so what I'm going to do is I'm going to find the mass number for R. So the mass number we are saying must be found by adding the number of protons with the number of neutrons, which is 12 plus 12 is 24. Then the atomic number is 8. The atomic number is 12. So if you go on the periodic table, the element correlating with this information is the magnesium atom. So we have magnesium here. Right, so we move on to question B. So question B is the combination of a bit of organic chemistry with more concepts, so we are going to deal with some calculations. So we have ethyl ethanoate with that chemical formula can be prepared from ethanol and ethanoic acid. So write the chemical equation for the reaction. So we are dealing with esterification. So the reason why is esterification is a reaction between ethanol and acid. So whenever you react an organic alcohol and an organic acid will give you an ester. So we need to come up with the chemical formula for ethanol. So for ethanol is C2H5OH plus for ethanoic acid is CH3COOH. Then we get our arrow. So since we are given the name of the ester, we are just going to, and the chemical formula is as well given, we're just going to write the way it is. So we have CH3CO2 C2H5 plus C. What else are we supposed to have? Remember, during esterification, water is also produced. Now, we have done the first part, and for equations like this, these equations are balanced. So if you look at, if you are able to count the number of carbons, we have 2 from alcohol and also 2 from the acid. So in total we have 4. Then we have 1, 2, then 4. Then oxygen, 1 from alcohol, 2 from the acid, so 3 in total. Even here we have 3 in total. So to summarize, our equation is balanced. Now after we are done, we can now go to question B. So calculate the theoretical yield of ethyl ethanoate, which can be obtained from 23 grams of ethanol. So we have actual yield and theoretical. Now theoretical yield is what you are expected to have based on calculations. For example, let's say you have a farm and let's say you plant maize, then based on the appearance, the growth of your maize, and you think of maybe this year I may get 200 bags. So 200 bags is what you are expecting to get based on what you are seeing, or plus based on the input that you put into your system. Then after the result, after the harvesting, you found out that you got 150 bags. So remember, what you expected was 200 bags, but you got 150 bags. So this 200 bags is the theoretical, because these were just made by calculations. They are like the assumptions. Now the actual is what you get. Okay, for example, if someone is expecting to get a 6 points, that is theoretical, is what you are expecting based on the effort that you are putting in, based on your studies, whatever that you do, but whatever that you do, you are doing for you to get that. So that is your theoretical, is what you are expecting. Let's say, for example, is like I said, you are expecting 6 points, then you get 8 points. So your 8 points is your actual, is what you've gotten. So that's what it means here. Now let's look at this point. Calculate the theoretical yield of ethyl ethanoate, which can be obtained from 23 grams of ethanol. So the mass of ethanol is given, which is 23 grams. Then our task is to find the mass of what this ester based on calculation. So we put X here. So what is our first step? We are going to find the relative molecular mass for each compound. So begin by ethanol. So from the chemical formula of ethanol, we have 2 atoms of carbon, so C times 2, plus 5 atoms of hydrogen, 6, so we'll say 5 plus 1, we just say 6, then plus oxygen multiplied by 1. The mass number for carbon is 12, for hydrogen is 1, then the oxygen is 16. 12 by 2 is 24, 6 by 1 is 6, plus 16. 6 plus 24 is 30, 30 plus 16 will give us 46. So we'll say C2H5 has the mass of 23 grams and the reactive molecular mass of 46. Then we need to solve for ethanoate. So CH3 CO2 C2H5. So that's what we are going to now find. So we need to find the reactive molecular mass for ethanoate. So the chemical formula is like this. So we can see that we have 1, 2, 3, 4. So we have 4 atoms of carbon plus hydrogen, 3, 8. So H multiplied by H plus we have 2 atoms of oxygen. So 4 times 12, 1 times 8, 16 times 2. So 12 times 2 is 24 plus 24, that is, so 4 times 12 is 48 plus 8 plus 32. So 48 plus 32 is 80 plus this one is 88. So I'm getting 88 as my final answer. Then here x we cross multiply. 46 times x is 46x. Then here we have 23 grams multiplied by 88 over 46 over 46 is same as the 23 times 2. Okay, so we cancel this. 2 here, here is 44. So we have 44 grams is what we are expecting to have whenever this, if this were to react completely. Now, the question is, if 33 grams of ethanoate is produced, calculate the percentage yield. So now this is the actual, because it's what they got. Now the expectation was to get 44 grams. Now why is that the actual is almost, or we can say is always less than the theoretical? Because during the chemical reaction, there are some impurities that may take part in the chemical reaction, and those impurities will result in the formation of the lower yield compared to what you expected. So here we are going to write our formula. So we have percentage yield is equal to actual. So always the actual is on top, divided by theoretical. So theoretical is the calculated. And in most cases, the theoretical, the actual is given. Then the theoretical, you need to make some calculations. So the actual is 33 grams over 44 grams. So the numerator must always be less than the denominator, because if you do the opposite, you are going to get a number greater than 100. So 33 divided by 44, getting 0.75 multiplied by 100, giving us 75%. So the out of the 100%, 75% of the reactant reacted completely, then 25% did not react. This may due to the presence of the impurities. So the impurities do not take part in a chemical reaction. Then question D, to which homologous series does ethylethanoate belong? So it is esters. So whenever you see this OATE, then it is an ester. We move on to question 5. The pH scale is used to indicate how acidic or alkaline a solution is. Then we have some numbers from the pH scale are given in the following list. Then what type of solution would have a pH of 1? So the way the pH is, 7 is the neutral. Then any number above 7 is basic, or the solution is in basic form or alkalinity. Any number less than 7 is acidic. Then if you look at the strength of an acid under the pH, as you move from the 7 to the left side, then the acidity increases. The opposite is also true for a basic. Whenever you move from the 7 to the right side, then the strength of the base increases. So if you look at the number that we are given is 1. So here we are looking at a strong acid. So the type of solution is acidic. Remember, it has to be strong. Then which pH value from the above list would be lime water? So lime water is a weak base, so this can be 7 or 8. So in our case, we will go with 12 since we are given numbers. Then pure water is neutral, we'll go with 7. Vinegar is a weak, so vinegar has a weak acid, which is 3. Okay, we move on to question C. So what would be the color of solution? So color of solution with pH value of 14. Color of solution of pH value of 14 when tested with universal indicator. So we are looking at if you put a solution with a pH value of 14, what color will it show? So the solution of 14, we are looking at basic. Then if that is put in a universal indicator, what color do we expect? So here we are expecting to have a violet or purple. So that is what we are expected to get from here. So it's a strong base. Now we move on to question 6. Some reaction of metals V, W, X, and Y are given in the following table. Then the first column is for metal. The second one, reaction with water, reaction with dilute hydrochloric acid. So V, a few bubbles form slowly in cold water. Vigorously reaction, gas given off. W, vigorous reaction, gas given off. Explosive reaction when reacted with dilute. X, no reaction, no reaction. Then Y does not react with cold water. Hot metal react with steam. Steam fizzing. Then question A, arrange these metals in order of decreasing reactivity. So decreasing, we'll start with the most reactive and to the least reactive. So from this, the most reactive is W, because we can see its vigorous reaction with cold water. So say W, followed by, after W, which one are we expecting to get is V, because here at least it is reacting with cold water. After W it's Y, does not react with cold water. Hot metal react with steam. Then after that we look at X is the last one because doesn't react with both water and dilute acids. Then B, which of these metals could be? The first one, magnesium. So it's metal Y. Why? Because magnesium does not react with cold water. Then copper. Copper is metal X. There's no reaction with water and no reaction with dilute acid. So it's metal X. Then question C. The equation for the reaction of W with cold water is given below. Describe the test for gas Z. So the concept is whenever a metal react with water, the products should be metal oxide. So metal oxide is where the compound has oxygen in it. Then the gas is always hydrogen. Describe the test for gas Z. So the gas is hydrogen. So say it puts off a burning splint with a pop sound. So whenever you put a burning splint closer to this gas, then it is going to, this gas will put off that splint with a pop sound. Then remember, to which group of the periodic table does metal W belong? So let's look at this compound, metal hydroxide. So this should not be metal oxide. We are dealing with metal hydroxide, unless if water was steam. So hydroxide, if you look at W, hydroxide has a valence of 1. So since the hydroxide is not enclosed in brackets, then W has also a valence of 1. So whenever I deal with a valence of 1, a metal with a valence of 1, these are always group 1. So these are group 1 elements. We move on to question 7. The following diagram shows two forms of carbon, P and Q. Name the allotrope labeled P. So P is diamond, Q is graphite. So you need to find ways of what should help you to remember these, because sometimes you may remember these two are allotropes, diamond and graphite, but sometimes you may find it difficult to identify which one is diamond and which one is graphite. So maybe the best way that I think I was using in my time was the letter G. So letter G is like this. So I used to follow this pattern and this pattern, therefore I have this and this. So that's what I used to do until I knew it. Then we go to question B. Explain the meaning of the term allotropes. So say different structure forms of the same elements that exist in the same physical state. So if you look at the allotropes, we are looking at two compounds made up of the same elements. So the same elements, or the elements that are found in diamond and graphite, are carbon elements. Now the only difference is how these atoms are arranged. So if you look at the atoms of carbon arrangement in this, you can see they are different. But to summarize, we are saying these two compounds are made up of the same atoms. So to maybe summarize the definition for allotropes, we are looking at compounds made up of the same elements, but different arrangement of those elements. Then what type of bonding is represented by these forms of carbon is covalent. So it's covalent bonding. Then B1, which allotrope named in A has a physical property which is typical of metals? So it's graphite. Set the property, it conducts electricity. So B, the reason why it is able to conduct electricity, if you look at the arrangement of these atoms and these atoms, so these atoms are able to move, and the electrons are able to move, so they are free to move. So whenever we have the concept of conduction of electricity, it's all about the movement of electrons. Question B8, the structures shown are members of one of the omega series in organic chemistry. We have R, S, and T. Give the general formula for this homologous series. So general formula is Cn H2n plus 1 OH. So how do we know these are alcohols? Because of the presence of hydroxide. So whenever you say hydroxide, then you're dealing with alcohols. What is the functional group for the homologous series? So it is hydroxide, OH. Then S is used as a fuel because it burns in oxygen. Write a balanced chemical equation for this reaction. So S has the C2H5 OH plus oxygen. Then whenever you deal with a combustion or a reaction with oxygen, you get carbon dioxide plus H2O. Now we have to balance, so we put a 2 here. Then we are going to put a 3 here. Now if you look at the number of carbons, 2 carbons, we've balanced. Then oxygen, we have 3 from water, 4 from carbon dioxide, so 7 in total. Here we just have to put a 3, so 3 times 2, 6, plus this one here, we have our balanced chemical equation. Then the last question is question D. Which of the compounds R, S, or T would have the highest boiling point? So let's go back. So T would have the highest boiling point because it is the one with the greatest number of carbon atoms. So 3 carbon atoms. So that is our T. So in terms of the boiling point, whenever the number of carbon atoms increases, then the boiling point also increases. So that's it for this video. Thanks for watching.